So I used to live in California, and one thing that Californians love to complain about is the Electoral College. Now, there are a lot of criticisms you can raise about the Electoral College, but many Californians feel that they are especially afflicted by its shortcomings. The argument I hear most often goes something like this. California is the largest state by population in the US with 39.5 million people. And it's true, they have the most electoral votes, 54 after the 2020 reapportionment. And that comes out to about 1.4 electoral votes per million people. Now, if we compare that to the least populated state, Wyoming, they have a population of less than a million, but still have 3 electoral college votes. This works out to 5.2 electoral college votes per million people. Now, the reason for this is built into the US Constitution. Each state gets a certain number of electoral votes based on population, but then each state gets 2 bonus electoral votes. So California got 52 based on their population, plus 2 bonus ones, whereas Wyoming only gets 1 based on its population, plus 2 bonus ones. Now, for Wyoming, getting those 2 bonus electoral votes makes a much bigger difference than it does for California going just from 52 to 54. In general, this means that larger states will see fewer electoral college votes per million people than smaller ones. Looking at a few other representative states, we can see that this pattern holds. Other relatively large states, like North Carolina, have fewer electoral votes per million people, and other relatively small states like Idaho get more. States in the middle, like Colorado, are in between. To put these differences in starker terms, we might define something called a representation factor. This is the amount of representation a resident of each state gets in the Electoral College as a factor of the average American. So to put an even finer point on it, Californians might complain that they only count as 0.84 of a person in the US, whereas Wyomingites might count as 3.2 people. You can think of these numbers as representing the percentage of the Electoral College votes allotted to each state divided by the percentage of the population in that state. So based on these numbers, it seems like Californians have a point. Californian voters seem to have less power than voters in any other state. But there is a question to ask, and that is the percentage of Electoral College votes really the same as the percentage of power? Now, I have to put power in quotation marks here because it's not a mathematical term. So my real question is, does it make sense to model the percentage of power controlled by a state as its percentage of Electoral College votes? At first glance, it seems like it should, but consider the following example. Imagine that instead of 50 states plus DC, we had a much simpler map with only 4 states: East, West, Central, and Other. Now, based on the populations of these regions, it might make sense to distribute the Electoral College votes like this. So in this hypothetical map, there are 100 electoral votes total, so you would need 51 in order to win a majority. Now, if we look at this map for a moment, we see that there's a big problem. The state East by itself already has a majority. Whoever East votes for is going to win. It doesn't matter who the other 3 states vote for. So in this example, East has 58% of the electoral votes, but in some sense has 100% of the power. They make all the decisions. And the flip side, of course, is that the other 3 states have no power. This is sort of an extreme case, but it illustrates why it doesn't quite make sense to say that the percentage of Electoral College votes necessarily corresponds to the percentage of power. Even though the West state had 22% of the Electoral College votes, they really had 0% of the power. Let's think about another example, this time not a hypothetical, one that actually happened in the real world. In New York. Well, not all of New York, but the Long Island County of Nassau County. So in the 1960s, Nassau County had 6 districts, each of which was represented by one member of the Board of Supervisors. Now, these districts each had different populations, and so the supervisors' votes were weighted accordingly. Districts H1 and H2 had the most votes, followed by OB and NH, and then followed by LB and GC with just 2 votes each. So that's 115 votes total, which means you'd need 58 votes for a majority. So, for example, if H1 and H2 both vote one way and everyone else votes the other way, H1 and H2 will still have the majority with 62. The same sort of thing happens if H1 and OB both vote one way and everyone else votes the other way, because H1 and OB have a total of 59 votes, enough for a majority. And finally, if H2 and OB vote together and everyone else votes the other way, they also have 59 votes, enough for a majority. So with those 3 examples in mind, we can see that any 2 among those top 3, H1, H2, and OB, suffices for a majority. Put another way, anytime there's a vote with just 2 options, the option with at least 2 of H1, H2, and OB will always win. Basically what this means is we can figure out which side is going to win by only knowing the votes of H1, H2, and OB. What does that mean about the other 3 districts? Well, if it's possible to figure out how the vote is going to turn out without even considering the votes of NH, LB, and GC, their votes aren't really relevant. Even though NH has nearly as many votes as OB, their abilities to influence the outcome are very different. In fact, a logical way to say that the power is distributed is to say that H1, H2, and OB each have a third of the power, and NH, LB, and GC each have none. Once again, we see that the percentage of votes that a district has is not a good representation of the amount of power that they have. So this brings us to the question, how do we measure power in weighted voting systems like the Electoral College? Well, there's more than one answer to that question, but the approach I'm going to take is called the Banzhaf Power Index. And the idea behind it is this. We imagine that all of the players, so in the Electoral College, I'm talking about the states, vote randomly and independently. Now look, that's not a good assumption. Politics plays a big role in how states vote. However, if we're trying to measure the power afforded to a state by its Electoral College votes independent of the politics of a particular election, then this is not an unreasonable assumption to make. It at least simplifies things greatly. So assuming that all of the players or states are voting randomly and independently, we model a player's power by the probability that their vote is decisive. What I mean by decisive is that they cast the deciding vote. If they had voted the other way, then the election would have gone the other way. Let me show you an example of what it means for a state's vote to be decisive. The 2004 presidential election was pretty close. Democrat John Kerry won 251 Electoral College votes, but Republican George W. Bush won with 286 Electoral College votes. Now consider Texas with its 34 Electoral College votes. If hypothetically Texas had voted for Kerry, that would have changed the result of the election. So we'll say that Texas's vote for Bush was decisive. Now consider instead Idaho and its 4 Electoral College votes. If Idaho had instead voted for Kerry, that would have changed the point total, but it would not have changed the result of the election overall. So for this reason, we say that Idaho's 4 votes for Bush were not decisive. So if we define power intuitively as the ability to influence the outcome, then it makes sense to model power mathematically in terms of how often your vote really does affect the outcome. That is, how often your vote is decisive. To see how this plays out mathematically, let's once again consider a simplified Electoral College map. This time there are 4 states with 2, 7, 3, and 5 votes respectively. Now let's consider all of the hypothetically possible Electoral College maps that could happen. If we assume there are 2 major candidates, then there are 16 possibilities. The winner of a particular map is the one with at least 9 votes, since there are 17 votes total. So we can figure out whether red or blue wins in each map. We can also figure out on each map which state or states cast decisive votes for the winner. So I've gone ahead and underlined the decisive votes for each map. In the very first and the very last map, none of the states are decisive. If any one of the states had flipped colors, the overall result wouldn't have changed. In the second map, the northeastern state is decisive. If the Northeast had instead voted blue, then blue would have won with 9 votes. However, the Southwest and Southeast are not decisive. If the Southwest had flipped to blue, red still would have won. If the Southeast had flipped to blue, the red still would have won. As one more example, we'll consider the third map, where both the Northwest and the Northeast states' votes are decisive. If either of those votes had flipped to red, then red would have won. We can then count up how many times each of the 4 states was decisive. We see that the Northeast was decisive 12 times, while each of the other 3 states was decisive 4 times. Now remember, we're assuming that the states are voting randomly and independently, so each of these 16 maps is equally likely. So we can find the probability that a given state is decisive by dividing the number of times they were decisive by 16. So we can see that the Northeast is decisive 12 out of 16 times, or 75% of the time, while the other 3 states are decisive 4 out of 16 times, or 25% of the time. Now, these numbers add up to more than 100%, and that's because in some cases, more than one state can be decisive at the same time. However, if we want to understand the percentage of power that each state holds, we can normalize so that the percentages do add up to 100%. In this case, we have to multiply by 2/3. Once again, we see that the percentage of Electoral College votes doesn't exactly line up with the percentage of power. In this case, the Southeast, Southwest, and Northwest all had different numbers of Electoral College votes, but they ended up having the same amount of power. So what about in the actual Electoral College? With 50 states plus DC, there are too many possible maps to go through all of them like we did for the 4-state example. But there are clever algorithms for figuring out the probability of decisiveness of a state without going through all possible maps. So if we crunch the numbers for the 5 states we looked at before, we can compare the percentage of the population, the percentage of the Electoral College votes, and the percentage of power held by each state. For all of the states except for California, you can see that the percentage of power, as measured by the Banzhaf Index, is almost exactly the same as the percentage of Electoral College votes. However, for California, the Banzhaf power percentage is 11.1%, even though California only has 10% of the Electoral College votes. And in fact, California is the only state for which there exists a big difference between the percentage of Electoral College votes and the percentage power as measured by the Banzhaf Index. Intuitively, California has so many Electoral College votes that it can throw its weight around a little bit and have an outsized effect on the outcome. Now, even with this effect in mind, California is still underrepresented if we compare its percentage power to its percentage of population, although less so than before when we compared its percentage of electoral votes to its percentage of population. In fact, by this measure, California is no longer the most underrepresented state. That dubious award goes to New York. And so really it maybe ought to be New Yorkers who are complaining that they only have 85% of the power of the average American voter. So it seems like the overall picture is about the same after this analysis. That residents of larger states like California, New York, North Carolina are underrepresented in terms of the power they wield as compared to their population, and residents of smaller states like Wyoming and Idaho are overrepresented. But this isn't the end of the story. There's one more wrinkle that ends up turning this whole story on its head. All along, we've been trying to figure out the percentage of power that each state has. But if you're a voter in a particular state, you don't really care how much power your state has. You really care how much power you have. Put another way, the states aren't the players. The people are. The voters are. All along, our goal was to see how much power individuals from each state had. And so, following the philosophy of the Banzhaf Power Index, we should be trying to figure out the probability that an individual voter casts a decisive vote. To give a specific example of this comparison, is it more likely that a Californian's vote decides the entire election, or a Wyomingite's? Once again, I'm making the simplifying assumption that all voters in the U.S. are voting completely randomly and independently. So how can one individual's vote decide the entire election? Well, two things have to happen. First, that voter's state must cast decisive Electoral College votes. But also, that individual voter must cast a decisive vote for their state. That means that the entire state must have been only one vote away from a tie or from going the other way. That state was decided by just one vote. Now, we've already established that larger states like California are much more likely to cast decisive Electoral College votes. But intuitively, it makes sense that it's much more likely in a smaller state that the vote could be exactly one vote away from a tie. It's very unlikely in any sized state, but it's more likely in a smaller state. So our question now is, who is more likely overall to cast a vote that decides the entire election? A Californian or a Wyomingite? Well, you need to crunch some numbers here. We've already figured out the probability for each state that they cast a decisive vote in the Electoral College. Figuring out the probability that a state is decided by exactly one vote requires some probability theory that I'm not going to get into. But once you crunch the numbers, the upshot is Californians are 1.75 times more likely than the average U.S. voter to cast a decisive vote, and Wyomingites are only 0.71 times as likely as the average voter to cast a decisive vote. And this completely flips the script on the analysis we did earlier. Whereas the Banzhaf factor seemed to suggest that residents of larger states were underrepresented and residents of smaller states were overrepresented, analyzing the power of individual voters suggests the opposite. By this measure, Californians have the highest voter power factor, and Idahoans have the lowest. You can see that Wyoming ends up having a little bit higher voter power factor than Idaho. Now, it bears mentioning that these voter power factors are based on these tiny, tiny probabilities that one voter casts a vote that decides the entire election. And you probably won't be surprised to find out that this has never actually happened. But it was pretty close once. In the famously close 2000 election, Florida cast decisive Electoral College votes for Bush. And while the state was not just one vote away from being a tie, it was pretty close. It was decided by a very small margin. And after the analysis we've done, it should come as no surprise that this happened in one of the largest states. Other smaller states have had narrower margins than what happened in Florida. Even in 2000, New Mexico was decided by a smaller margin than Florida was. But New Mexico also has fewer Electoral College votes, and so that's why it wasn't decisive. So look, the way that I modeled voting power here is not the only way to do it. For starters, I made some assumptions that just aren't true in the real world, like voters voting independently and randomly. But if there's a takeaway here, it's that the power dynamics in the Electoral College are more complicated than they might appear at first blush. And that the narrative that larger states are underrepresented and smaller states are overrepresented in the Electoral College isn't the only way to look at things.